Welcome to an example of graphing an inverse function. So they're giving us the graph of y equals f of x is shown. So this is f of x. And it's asking us to sketch the graph of, and that's might be funny looking, it's the inverse. This is the graph of the inverse. So they're showing us the graph of a function, a linear function, a straight line, f of x, and they want us to take that graph and use it to find the graph of the inverse function. So the question is, how does an inverse function graph relate to a normal function graph? What's the connection there? Well, remember, for an inverse function, what do we mean by inverse function? What is inverted? You invert. Remember the first step in finding an inverse function. What's step number one? You invert or switch x and y, right? That's what's inverted. That's what it means to be an inverse function. The x values and the y values have switched. Okay, so then let me make a little table here. Here's f of x, and then right next to it, I'll put f inverse of x. And then let's go find some points that are on f of x. Like, how about this point right here? What's the coordinates of that point? Over 0, down 2, right? So over 0, down 2. So that becomes, for the inverse function, what's that same point going to become for the inverse function? The x and the y are going to what? They're going to switch. So it'll become minus 2, 0. So let's find that point. Back 2, up 0 right here. Right there. So back 2, up 0. So that's the corresponding point on the inverse function. Let's do another one. How about, here's a nice, I'm just picking ones that are easy and obvious. So there's one, 3, 0. So 3, 0. And what is that going to correspond with in the inverse function? You just switch the order because that's what an inverse function means, an inverting of x and y. So that would be the point on the inverse function of 0, 3, which is right there. 0, 3. Now that's enough. All we really need is 2 dots. That's good enough. In fact, actually, let me move that one over a little bit so we can have room. Okay, so let's draw the graph. So I'm gonna actually draw the inverse function graph now. Let me see where I'll start. I'm going to start right here, down here. There it is. That's the inverse function graph. Actually, let me move that over here. So that is the inverse function graph. Of course, you know, there's arrows. It goes forever both directions. Here's the original function, f of x. And notice something about that graph. If we take right in the middle a diagonal line, let me do that. If we put this line, this is the diagonal line right through the middle. This is the line y equals x, the diagonal that goes right through the middle. See, that one goes right through the middle of the axis system. It's the line y equals x. Why do I say it's the line y equals x? Because every point on that line, like this point and this point and this point and this point, etc., all of them have the same x and y values, right? Like this is the point 1, 1, this is the point 2, 2, this is the point 3, 3. Every point on that line, the y and the x are equal. We call that the line y equals x. Let me get rid of that. So that's the line y equals x. So okay, so great. So what am I saying? I'm saying notice that an inverse function and a regular function are mere reflections across the diagonal line y equals x. See how it's just a mirror image? That's always what an inverse function graph looks like. So if you have an original function f of x over here, the inverse function will be a mirror across the diagonal line y equals x. Why? Because that line, the red line, y equals x is where y values and x values are exactly equal. So an inverse function, we're inverting x and y, so that graph will be on the exact opposite side of the x equals y line, or the y equals x line, same thing. So an inverse function is always a mere reflection across that diagonal line. It always works that way. And all we had to do was start with 2 points and flip them both. By the way, you can see further, we're done now. There's no more work that's needed, but I want to show you how it's true for other points as well. Like how about, here's another point clearly on the original function. What's accordance to that one? That's over 6 up, 2? That means the point, so if I put that down here, 6, 2, that's got to correspond with what? 0.26 on the inverse function. Let's find 2, 6 over 2 up 6. Boom, right there. See how it's true? That point is exactly on the inverse function. See how you could draw this connection. Let me show you one more thing. You could draw this connection. See how these and these and these reflect perfectly across the diagonal line. See how they just mirror image across? So that's what an inverse function graph is. It's the mirror reflection across the diagonal line.